Hey guys. So today's topic will be about CDK. CDK is a framework that AWS has developed to facilitate the creation of AWS services in a declarative and programmatic way. It's important for multiple reasons, and I will go over some of those. Let's get started. Well, this is yours truly. Please subscribe and follow me on Twitter and a bunch of other social networks. And definitely subscribe to my YouTube channel. Thank you all for subscribing already. I think I had like 100 subscriptions in 2 days, which is nice. All right, so when you need to work with AWS, you obviously need to create AWS services. Well, one obvious way of creating those services is by going to the console and clicking through the console, clicking on the appropriate buttons, entering the appropriate information, and creating those resources. Yes, there's other ways of doing it, which is maybe you can use the service catalog, which simplifies the creation of those resources. Or you can go to the marketplace, and marketplace provides, I would say, ready-to-use solutions for you. There's other ways of doing that. But at the end of the day, a lot of times you'll still need to create some custom resources, and you would still need to go to the console, to the UI, and create those. So, it's a great starting point. And actually, I recommend it to a lot of people and a lot of customers because they learn all the ins and outs of these services using the console, right? So they learn about the parameters, they learn about the interaction of those parameters, the um, relationship of those parameters and things like that. So it's really good to at least once go through the UI and actually create resources that you want to then declaratively create. But as you can imagine, it's not very efficient. So a really good approach is an imperative infrastructure as code approach. What does that mean? Well, you use the AWS CLI to declare the AWS services. So as an example, if I need the S3 bucket, I would use the AWS CLI command to create the S3 bucket by saying AWS S3 and then create bucket, or whatever command it is. So you can bundle all of that code in a deploy script, and you can share it or you can run it, and you can basically check it into Git, and then you can make sure that it's version controlled and things like that. But as nice as it sounds, there's a lot of potential problems with this approach. So the first one is the amount of time that you need to spend to actually create the script, right? Because now you have to learn the endpoints for all of those AWS services that you're actually trying to create. So AWS S3, as an example, has a whole bunch of endpoints that you need to understand in order to figure out which one to use, let's say, to create something, or to list and get the newly created bucket name or some other parameters from that bucket. So there's a huge learning curve there, right? Now, there's a lot of boilerplate as well, because you have to recreate a whole bunch of code every single time. So you have to have if statements to make sure that if something fails, then you want to make sure that you either retry or you back off and delete all the other resources. So you have to have a lot of best practice patterns in mind, such as if you have already created 3 services and the 4th one fails, well, what do? Do you roll back the other 3 services, or do you continue with the deployment, just skip the 4th one, and then the next time the script runs, you want to make sure that you don't fail if those first 3 services are already existing, right, or have already been created. So there's a lot of code that you need to write to make sure that this code the script is repeatable and the script actually works more than once or even the first time. And you also have to figure out what is the situation that you will be in if, let's say, two people run the same script at the same time. What about race conditions? So things like that will make your life, I'm going to simplify this, a living hell. About 3-4 years ago, I was creating these scripts a lot, actually. And I went through all of those steps, and from personal experience, I know that there's a lot of steps to figure out. There's a lot of steps there's a lot of conditional logic that you have to create in order to make sure that the script is properly written and is ready to use for production. So a much better approach, is the declarative approach. What that means is you basically provide some kind of a file, might it be a YAML file or a JSON file, that specifies which services you want to create and what are the parameters and parameter values that you want for those services. So it's a really interesting approach where you don't actually work with the SDK, with the AWS SDK. You use a service like AWS CloudFormation or Terraform, and you rely on that service to invoke the AWS SDKs, which is great because, first of all, there's much less boilerplate. And as you can imagine, this is one of the text files or YAML files that you can specify or you can supply. So in this particular case, it's very clear. You specify that you want to create a VPC and what type of a VPC. You specify the parameters like DNS support set to true, DNS host name set to true, and you specify the CIDR block. You basically specify the availability zone. So you declare what your infrastructure is going to be like, right? What the end result is going to be. So some of the biggest advantages with declarative infrastructure as code is that it takes care of the configuration drift for you. And idempotency as well is very important. What that means is every single time you rerun the script, or you basically pipe the script into the service, you will get exactly the same result. So as an example, if you're using the script to create your environment in development, and then you use the script to create it in the production environment, you're going to get two exactly the same environments, which is really cool, right? Because you want to make sure that your development and production is the same. And repeatability is also in line with idempotency, right? So you want to make sure that you can recreate your environment if need be. State management, Terraform and CloudFormation make sure that it understands where your resources are at that moment. Extensibility, you can always extend the functionality of those services, and the knowledge base. Those two services have been around for a while. So it's definitely something to consider when you are looking for a declarative way of creating AWS resources. But in my opinion, there's even a better way. And that way is the AWS CDK way. So CDK is a framework that was created by AWS. And what it allows you to do is to use your favorite language. If your favorite language is one of the four that I'm going to list. And it allows you to create all of your resources using code, which then is compiled or synthesized using the CDK terms into CloudFormation, and CloudFormation then takes it from there and creates all of the resources. I have no idea why my image has stopped. So let's see. Let's try it again. Yeah. All right. So second. All right. Not that I want to look at myself, but from what I understand, it's much easier to follow if there's an actual face to the voice. So this is what a CDK stack would look like. And just to make sure that we use the proper terminology, there's three main terms that I'd like you to walk away with after this presentation. So the first one is the app. Second one is a stack. And the third one is a construct. So an app consists of multiple stacks, one or more stacks, and a stack declares one or more constructs. So a construct might be mapped to a specific AWS service or a higher level mapping where it might cover multiple services, or it might cover a specific, I would say, feature of a service. But basically, a construct is the smallest, call it the smallest configuration piece, right? So in this particular case, the VPC in this code snippet is a construct. A cluster is a construct. The application load balancer is a construct. And the stack is going to get deployed as one whenever CloudFormation is invoked. So you will see in the CloudFormation console, you will see each stack listed separately. And each stack can be removed separately as well. So in this particular case, you can use JavaScript, you can use Python, you can use Java or C#. So in my case, I actually created a Java application that I'm going to share with you. And I already went and installed it just because it takes some time, but I'm going to walk through the code. So the advantages are multiple, right? So you write in your language, in the language that you appreciate and know. It takes away most of the plumbing, and I'll show you in the next slides what I mean by that. And it's very much declarative. It's still very much declarative, but you can actually add custom logic to your declarations, right? So you can add those conditional statements and based on some logic, maybe based on some outside external logic, you can figure out what to deploy and what not to deploy. So let's take a look at this particular construct, right? So this VPC construct, when you compile it and you synthesize it and you deploy it, it creates a whole bunch of different features and I would say services for you, right? So NAT gateway is one, internet gateway. It creates a whole bunch of subnets for you. So this one line translates into 270 lines of actual CloudFormation YAML text, which is a lot. It's definitely not something I would want to write by hand myself. So the way the CDK team has approached this is every service has its own package. So as you can see, you have the AWS ECS package there. But for some packages, for some services, they created an additional package. As you can see, the ECS patterns package in this particular case, which tries to simplify even more, even to a greater extent, the bare bone constructs, right? So as an example, in this case, these, 5 lines of code generate a Fargate ECS service, meaning it also generates the ECS cluster for you. And it also generates the application load balancer that will route the service from a particular, that will route the service to this particular Fargate service, or the route the request to this particular Fargate service. So in this case, you can also see that a container image is being declared. And what this means is it will actually deploy this particular container image upon installation. So it's great. It simplifies a lot of the boilerplate even more for you. So let's take a look at some code. All right. So this is the project that I was mentioning, and let me show you where it lives. So this is my account. This is the CDK project. This CDK project, it's very simple. The idea behind it was that I was going to create a sample application, and I'm still working on it. I need maybe another week or two. But in order for me to create a sample application, what I wanted to do is create the resources for it. And I started digging a little bit, and I figured that CDK is a great service, so I started working with the CDK for my resource needs. Even though previously, I used to work a little bit with obviously CloudFormation, then with Terraform. And for my serverless needs, I used to use either the serverless application model or the serverless framework, mostly the serverless framework. So in this particular case, these are the resources that it will create. And I think my Mac is about to blow up. So these are the resources that it will create. As you can tell, these resources, they're quite popular, right? So you have an S3 bucket, you have an ALB, you have a Fargate service, you have Cognito. They're popular in the world of application development on AWS. And there's a Kinesis stream, and there's an Elasticsearch cluster, and then a DynamoDB table or two. So here's some instructions on how to run it, and this is what I did actually right before this presentation. The reason is it takes about 30 minutes to actually create all of the resources, mostly because of the Elasticsearch cluster. It takes a little while to create the Elasticsearch cluster. Now, this is what you get at the end of running these commands. You get a whole bunch of stacks with a whole bunch of resources. You can remove each one of these stacks, and you're not going to impact the other ones. And I'll show you how they're mapped here, which is really cool because let's assume that you no longer need a stack. So as an example, let's say I'm no longer needing the Cognito stack. I'm using something else that I created myself, right? I can remove this Cognito stack from here, and I can also remove it from my code or through my code, and I'll show you what I mean by that. And it's not going to impact the other stacks. They don't have to be upgraded or redeployed and things like that. So let's take a look at some of the code, right? So this is the app that I was mentioning. This is where you declare all of your stacks, where you initialize all of your stacks. And what you initialize here is what will be deployed. If you don't initialize it here, it's not going to get deployed to your AWS account. So as an example, you see this ticker DDB tables? It's right here. So it's a one-to-one mapping, right? So if I were to create two of them, there's going to be another ticker DDB table here, but it's going to be ticker DDB table 2. And it's actually a really cool idea, right? It's a really cool way of creating those resources, because in this constructor, I can pass in the table name, the new table name, and I can overload this constructor. And basically, it's going to simplify the creation of these resources. So this is how I create the Kinesis streams and everything else. Now, what I want you to pay attention to here is that here I'm creating Lambda functions that will be consumed or will be declared in the actual Cognito by the actual Cognito service. The way CDK compiles and creates these resources, is basically it tries to figure out the dependencies itself. And um, by trying to figure out the dependencies, most of the time it worked for me. But there was a couple of times where some of those dependencies weren't kind of formulated properly by the CDK framework. So my installation scripts failed. So what I had to do is I had to actually explicitly set the dependency. So here, this Cognito stack, I set the dependency on this Lambda stack because I cannot create a Cognito stack before I create my Lambda stack. Since the Cognito stack actually requires me to declare Lambda functions, and if these or declare the use of some Lambda functions. And if those Lambda functions don't exist, then the installation fails. So if you look at this particular instance here, so this is where I reference the Lambda functions. Most cases, and maybe it's going to work with this new version of CDK that I just upgraded to, but in most cases, CDK would sense that these Lambda functions needed to be created first before this Cognito stack. Now, I don't remember if Cognito was the culprit of why I had to do what I did, but I think it was Elasticsearch. But I had to actually explicitly declare those dependencies. Now, don't mind me using static variables here. Usually wouldn't, but this is a different kind of a Java application, so I decided to cut some corners here. But basically, this is what I had to do here for Elasticsearch. This is where I had to declare the dependency between this IAM declaration or IAM role and Elasticsearch. So this is the gist of this framework. It really simplifies the whole AWS resource creation, and it really lets you concentrate on business logic rather than the boilerplate sysadmin logic that you would otherwise have to concentrate on. So at this point, I just want to show you one other thing. I want to show you the Fargate service. So a really cool way of creating your Fargate service is using CDK. I've used the ECS CLI, which is also a breeze to use, especially recently, as of recent. But with this framework, it just makes it even easier to use, and it's really easy to kind of get a grasp of what's needed. So as you can tell, you have this Fargate cluster. Everything was created. It has 2 tasks that are running right now, and everything is being pulled from the image is being pulled from this data ingest gateway repository. Now, in order for me to declare that, let's just go in here and show you. This is all I needed to do. This declares my Fargate, and this might seem a lot, but it's really not. And the reason I went this route and not the ECS patterns route is because I wanted to add multiple services to my ALB, which I think I figured out how to do it properly, but I don't really need a second one, but I really just wanted to learn how to do it. But basically, this is how you would create a Fargate service. And again, you can use the ECS patterns if you just want a one-to-one mapping. So if you want an ALB to a Fargate service mapping, you can use the ALB Fargate service class that's declared in the ECS patterns package, and it's just a matter of like 5 lines of code, which is really definitely easy to use. That's about it. If you have any questions, write them in the comments section or send them my way. If you have any requests for future topics, please let me know. If you want me to dive deeper into the actual CDK framework, constructs and best practices and things like that, also let me know, and we'll take it from there. Thank you for listening.